Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, we start our lecture. This one is on the first chapter, Kinematics of Particles. Okay, for the EMM 3105 Dynamics. For those who are taking Bachelor of Aerospace Engineering at UPM. Okay. Okay. For this particular topic, we begin with a subtopic of kinematics of particle. We look into the rectilinear motion. Okay, under this rectilinear motion, we have continuous motion, erratic motion, and also general motion. Okay, for the continuous motion, what we have here is we are going to deal with. First of all, we would like to introduce the definition of what is kinematics. Kinematics is study of the geometry of motion, relates to displacement, velocity, acceleration, and time without reference to the cause of motion. Okay? On the other hand, for the kinetics, it is a study of the relation existing between the forces acting on the body, the mass of the body, and the motion of the body. Kinetic is used to predict the motion causes by the given forces or to determine the forces required to produce a given motion. Okay. To differentiate these two between kinematics and kinetics, in simple way is if you are dealing with kinematics, normally the forces is not included. Okay, when you are dealing with kinematic, you are only interested with the motion. Okay. Okay, on this right hand side, what we have here is a racing car. For this one, it is more on the kinetics. Okay, if if we analyze it, just the motion of the car, the path of the car, we just look into the kinematics. However, if we want to analyze the kinematics of it, then all the forces involved will be included. Okay. Okay. Particle kinetics includes rectilinear motion, position, velocity, and acceleration of a particle as it moves along a straight line. Okay, straight line because this one is a rectilinear. However, for the curvilinear motion, position, velocity, and acceleration of a particle as it moves along a curved surface in 2 or 3 dimensions. As you can see, this solar car is traveling in a straight line. So this one, we consider it as a rectilinear motion. And on the right-hand side here, there is a train. There is going through a curved pathway. Okay, so this we consider it as a curvilinear motion because it has to deal with the both two axes actually. Okay, either x and y, or y and z, or z and x. Okay, so it's depend on your reference axis. Okay, rectilinear motion, particle moving along a straight line like this. Initially, the red dot here is at point on the left, then move to the right, point stop at point B. Okay, and for the position, coordinate defined by positive or negative distance from a fixed origin on the line. So if your coordinate system telling that to the right is positive, to the left is negative, and you can see that on the second image down here that the x prime here is going to the left, and therefore we'll have a negative distance from the fixed origin. Okay. The motion of a particle is known if the position coordinate for particle is known for every value of t. It may be expressed in the form of a function. Okay, function can be like this: x equal to 6 t square minus t3, t square minus t power of 3, or t cube. Okay, and over here on your left, we have a graph that represent the distance or the pathway traveled by this particular particle. Okay, okay. When t equal to 0, you can see that the position of x is equal to 0. You can easily substitute the value of t equal to 0, and when t equal to 0, this first term will become 0, and this term also will become 0, and therefore x is equal to 0. So x equal to 0. Then if you replace, let's say you put the value of t equal to 2, and you can see that 2 square become 4, 4 times by 6, 24, minus 2 to the power of 3 is 8. So 24 minus 8 is 16. So therefore, when the value of t is 2, you can see that the x is 16. And you can also calculate for any value of t, and you can see that the path of this particular motion is like so. Okay. Okay, now we consider particle which occupies position p at time t, and we denote it as a p prime because p has moved from one place to the other, that we can have another delta t, or is simply we can refer to this particular image here on the left, where initially the P is here at point O. Sorry, the particle is at point O, and then it moves for a certain distance x, and while moving to the position at P, what happened is the time travel is denoted as a t, and then it moves further forward, and at a distance of delta x, and also with another delta t, and therefore the total time travel from point O to point p prime would be t plus delta t, just like that. Okay. Okay, if you would like to look into the average velocity from point P to P prime, you just simply get the delta x over delta t, which is the distance travel. Okay, and speaking about the instantaneous velocity, the difference is that for the average velocity, you calculate, you get the mean of it, okay, the average of it. However, the instantaneous velocity will be depend on the exact time that you might interested in. Okay, so that's why we call it the instantaneous velocity. Instead, the instant time that that the particle move, or where was it at that particular instant time. And the instantaneous velocity may be positive or negative. Magnitude of the velocity is referred to the speed of the particle, because we are talking about the magnitude. So magnitude is a scalar, and therefore we call it a speed. However, if you are looking into the not only the speed but also the direction, then we might call it as a velocity, because velocity is a vector. Okay, as I just mentioned just now, that if you are interested to look into the instantaneous position, okay, you can put any instant time that you might interested in, so that you can get the exact position, the x value of that particular particle, and then the same thing for the velocity. You can just differentiate this function, okay, to get this velocity function. So it is differentiate with respect to time, and therefore you will get 12t minus 3t square. So if you would like to know the speed, okay, of it at any time, you can simply put any value of the t here, and you can also get the plot of graph like on the left here. Okay. Okay. Consider particle with velocity v at time t, and then we also have v plus delta v, where there are change from one position to another position, from p to p prime, and there are also changes in the speed. Okay, the speed is changing. Okay, we can say from v to v prime. Okay, so when the velocity is changing, of course you will have a delta v, and also you can divide by delta t, and you will get the acceleration, because acceleration is the changes in the speed over the changes of the time travel for that particular condition. Okay, now we move into the instantaneous acceleration, that we can consider it as a positive when the velocity is increasing. Okay, when the increase in the positive velocity, okay, the acceleration will become a positive. Okay, a is bigger than 0, so it is a positive. Okay, or it become a okay, if let's say just now point P is moving to the right, but now it is moving to the left. Okay, but still you can see that the acceleration is a positive value. Okay, because it is a decreasing negative velocity. Okay. Okay, for the negative, the acceleration will become negative when the positive velocity is decreasing. Okay. To make you more clear, what happened here is, let's say at point P, the velocity is 10. Then at P prime, the velocity become 12. So from 10 to 12. So it is increasing. But then if let's say it move on the reverse direction, what it means by negative velocity decreasing means that the velocity at P, let's say 10, but at point P prime, the velocity is decreasing, means the velocity become 8, for example. So it is decreasing, right? So the total, if you do the maths, it become a positive value for the acceleration. Okay. And the same thing here, if the positive velocity is decreasing, okay, just now we are talking about the positive velocity increasing, but now we are looking into the positive velocity where it is decreased, okay, the acceleration become a negative because of at point P, let's say it is a 10, but at P prime it become 8. So if you do the math, it become a negative value, okay, because V prime minus V divided by delta T, so you get a negative value. Okay, the same like before, that if you increase the negative velocity, means on the reverse direction, the acceleration become negative if you increase the negative velocity. Okay, negative velocity means negative velocity is the direction. So initially it is 10, but then it is increased to 12. Okay, so the acceleration become negative. Okay, from the definition of derivative, A is equal to delta V over delta T, or simply you can write it as dV dt. And you know that dV is actually dx dt. So dV is dx dt, then again you divide by dt. So you will have d2x divided by dt square. Okay. So for example, if you have this function here, v equal to 12t minus t 3t square, if you would like to get the acceleration function from this particular formula, what you can do is just differentiate v with respect to t, respect to time. Therefore, you'll get this function 12 minus 6t, and you can see that is the plot on the left, okay, where the y is the intersection at y-axis, which is 12. Okay, you can see that it is 12. And then you have a minus 6, the slope of these particular lines. And t is normally represent something on the x-axis, where you can change the value accordingly. Okay. First, we look into this particular example, short example. A ball is thrown vertically upward with a speed of 15 meters per second, and you need to determine the time of flight when it returns to its original position. Okay, what happens is you grab a ball, throw it upwards, and then it lands back to you, and you basically catch the ball. Okay, what happens is this is the general formula that you can use. Okay, the derivation I will discuss with you later in the class. Okay, okay, we have S, the final position, equal to the S naught, which is the initial position, plus the V naught, which is the initial speed, times T, total time, plus half AC, AC in this case, because it is moving in the vertical direction and against the gravity. And you can see we have a minus sign here because it is going up, right? And T square. So you just plug in the value. We know that it start and end at the same position. So it start from your height or from the ground level, and then it's end also at the ground level. So both the value will become 0. And V naught is given here that is thrown vertically upward with a speed of 15 meters per second. And just put the V naught is equal to 15. And you know that this AC is the acceleration of the gravity, and the minus sign represent the it is going up, okay, because acceleration is the direction is going down. So that's why we have a negative sign. And you just use normal maths to get the roots of this t value, and you can ignore the negative value. Just when you do the maths, you will get two values. One is negative, one is positive. You just pick the positive value. That represent the total time, the time of flight when this ball returned to its original position. Okay, on the second example, a particle traveled along a straight line with an acceleration of 10 minus 0.2 s. Of course, it is in meter per second square, where s is measured in meters. So s represent the distance. Okay, we need to determine the velocity of the particles when the distance s is equal to 10 meter. If the velocity, the initial velocity is 5 meter per second. Okay, why I said initial velocity? Because it's given that v equal to 5 meters per second at s equal to 0. So s equal to 0, probably the initial position, and initial position is our initial velocity lah. Okay, from the derivation we can see that if you would like to get the formula on how to resolve this particular problem, you can look at the first principle of the acceleration, where you can relate that with the distance, where acceleration is a dv dt, and dv itself, you can split that into ds dt, and you can expand that more to get this particular expression. Okay, then you can do the integration with v, of course, with respect to dv, and this expression given here, because you have s here, so you can use ds to solve this. Okay, and we know that the initial speed is 5 meters per second, and we don't know the final speed yet. And the initial position is also given as 0. Okay, then you can do the maths, and you get this particular expression. And since we need to determine the velocity of the particle when the distance is at 10 meter, let's say from here to here is 10 meter. So that is what we are looking at. We want to know at this moment, at this point, what is the velocity. So using this, the expression that you have, that you get, just simply put the 10 meter value, then do the math, then you get at that particular position, it is travel at 14.3 meter per second. Okay? And the direction is to the right. Thank you.